This evening, we've got two gentlemen from Royal Precision Lubricants, correct? Yep. I was speaking to John Payne just recently, and he mentioned that with his new the race car he's building, he's going to be using these guys' oil in his race car, and I noticed a livery on John's race car. So John mentioned to me about this company, and they decided they'll come along and talk to us.
Thanks, Gary.
Okay, Brett Bates and Bill, surname? Slegtenhorst. Thank you very much. I was desperately trying to remember it.
Not German, but it was close. Yeah.
Just next door, isn't it? All right, thanks, Gary. I'm going to start off just very briefly. I'll give you a bit of an overview of who we are, because probably most of you haven't heard of Royal Precision Lubricants before. We've been around for over 25 years. Started off as a brand in Melbourne. We are an Australian-based and owned company, pretty much a family business, in fact, and we've been operating, as I say, for 25 years. We manufacture and market lubricants, obviously, and we do a very broad range of lubricants, including engine oils, gear oils, transmission oils, hydraulic oils, and so on, but we don't do everything. So, there's some very specialised lubricants where the market's not big enough for us to get involved in, and so we don't do those, but we do all the common ones, and they're all marketed throughout Australia, New Zealand, and even partly into Southeast Asia. We've got two blending facilities, one here in Brisbane at Narangba on the north side, and another one in Melbourne at Dandenong South, and we blend around 4 million litres a year between the two sites. We operate under a quality assurance system, which is third-party accredited and conforms to the international standard ISO 9001, and we've had that accreditation now for over 20 years. We also have warehouses in Townsville and Perth, so we're spreading our wings, and it's probably fair to say that our growth has been more significant over the last 7 or 8 years. The early years it was a very slow start. It's a very competitive and difficult industry to get into, but that's where we are. So that's a bit of a brief of our company, and what we thought we'd do now is get Bill to give you a bit of a talk, if you like, on lubricants, and not go into too much technical detail, but give you an idea of how they work, right?
Look, I'll just give you some of my background. And I was told originally that there was only going to be 10 here tonight, so my apologies. I did 15 of those briefs up. But my background, I suppose, is a lot of motorsport, 45 years in engineering, mechanical engineering, and in the lubricant business. A lot with lubricant design at the time for a lot of race vehicles. Some of you may still remember Frank Gardner and the Benson Hedges vehicles. Some interesting stories there with him, but anyway. Also with Larry Perkins, had a lot to do with Larry in those days. Drag racing with Victor Bray, and then we had Australian champions with Formula One boats. At the time, tunnel hull boats, Formula 3s and that sort of thing, motorcycle side of the business, and that's we've got a fairly strong sort of history in that. Actually, one of the Frank Guards, I remember that they had a Norwell track that they were racing down there. We were down there one day and they rolled. What used to happen is that if you bought an M series, you got, I think, 3 days, was it, on the track? 1 day in the M and the other 2 days in the 5 series. So this little Asian fella was out with his instructor on the second day, managed to roll the 5 series out there. And as they're peeling him out of the car, because they thought they'd killed him, so they're trying to get him out of the car, and he dusts him off and all that, and he goes, "New car, please." And Frank was not impressed, but anyway, with the driving school, so you can imagine how he went with the M series out there anyway. But we did some track time and that sort of thing with, I think Paul Morris, I think it was at the time around there, and with Tony. Had Tony out at Lakeside, we did our dealer day and that sort of thing out there, and Frank absolutely tore him apart because he's gone, he actually used it as a test and tune while we were taking people out in the car, lost it, spun the vehicle out, came back, the guy that was in the car with him was probably about 70, and I think he aged another 10 years by the time they got him out of the car. He's just, yeah. So, but anyway, look, so from my side of it, if you want to talk racing and that sort of stuff, I'm more than happy to talk about it later on. But just look, with the lube side of it, there's been an enormous amount of changes over the years where, before 2050, even your old 2002s or whatever it was, BMWs and that sort of thing, 2050 was the going thing in those. So what's happened is that dramatically fuels have changed in vehicles. So we've seen waxes, sulphurs, everything we moved out of it. You'll notice that a lot of mechanics these days are wearing nitrile gloves when they're servicing vehicles, because the byproducts of combustion now that are coming out of those engines at those temperatures, and really unleaded fuel is now more a chemical concoction than anything else. We always say that our lubricants are fine, for humans to touch, to be in contact with and that. However, once they've been running an engine, there's some very nasty chemicals come out through that. One of the other things that we've seen is a dramatic change in viscosities in the oil. And viscosities meaning the thickness of those oils that we used to run in there. And just to give you a little bit of an idea, is that your latest vehicles now are running a 0-20, and some of these new BMWs you have here, particularly the LL17, I think it is, and long life 17. So just a simple thing to show you, that test tube there is a 2050, that test tube there is a 0-20. And you can see how much quicker that goes through the engine now on startup. Okay, so huge differences in that oil. The frightening part of that is that 0-20, what we're up to now, industry is now looking at 0-16, and then they're looking at future of 0-8. And what that means is that a 0-8 oil at 100 degrees is the same thickness as what diesel fuel is at ambient temperature. So at 100 degrees, that oil is the same thickness as that. So you're looking at very tight tolerances that are coming into these engines. It would be very difficult to rebuild those motors back to an original specification, simply because in the factory now they're just that tight. They're just working that well with those. But I was just trying to get a handle of the mix of the people that we had in the group, because obviously some are going to be fairly still technical, race-minded and that sort of thing. Others really don't care, they'll just put the car in, have it serviced, and they do whatever the dealership tells them to do. So again, we're just trying to understand for you guys just the differences in base oils. So what we found with our reps and the training that we give our reps and that sort of thing is, when everybody has an opinion on oils, and it's usually engine oils that they're opinionated on. That's the only thing that's emotive about it. I mean, picture it yourself, you might show an interest in what they're putting in your engine, in that vehicle, and considering that front to back, every turning component in that vehicle, from engine right through transmission, differentials, all has to be lubricated in some way or another. So you'll show an exhibit, an interest in what goes into the motor, but you don't really ask what brand of brake fluid that they put in there. You don't care, as long as they do. And yet, it's an extremely important component of that vehicle. And so again, transmissions now, they've developed that far now that we're 8-speed, 9-speed, 10-speed transmissions in those. I remember doing a talk 20 years ago to an automotive group, and we're talking about transmissions then. I was telling them then that we're going to go from 3-speed to 5-speed transmissions, and they all looked at me like I had fleas. They just couldn't believe that we're going to go to 5-speed. So to get your power to the road now in these motors, the horsepower that they're putting out, and then the fuel requirements, the emission requirements of them, that's why we're going to these type of transmissions. They're all computer operated now. There's very little manual stuff in there. The lubricants that go in there now is, we've gone to LV, I think now in these ones, which is a very light viscosity, automatic transmission fluid. You're seeing CVT transmissions coming in. God help anybody that puts on a normal automatic transmission fluid in the CVT, it will grenade badly. So they're a completely different way of operating. So differential-wise, you're now seeing dealer-only products for in differentials, that sort of thing, when you look them up. If in any doubt, we do have a website that you can go to which does have all your vehicles and models and everything like that on there. You can actually cross-reference those if you want to across from that. But really what I was just going to sort of talk about was how we were going and understanding, in base oil. So we're starting from Lubricants 101 in a way for people that don't understand all of that. But when you're looking at your base oil categories, they start out as tree and dinosaur juice at the end of the day. That's really what it is when it comes out of the ground and then it's processed. And there's three basic ones. You've got paraffinic, you've got naphthalenic, and you've got aromatic crudes that come out of there. Paraffinic is your main one. Like the paraffin-based oils is what your lubricants are mainly made out of. There's some very specialised one that comes out of your naphthetics, which is like your refrigeration type oils where they're using ammonia and that type of thing. But mainly you've got your paraffinics, the building blocks for all the different types of engine oils and transmission oils. You then run from those, you run into your synthetics. Synthetics, it's a fair sort of a stretch these days, isn't it, Brent? What they call a synthetic. And when you look at these are lubricants come in different groups. So group 1 is your old type, earlier type of base oil lubricant, and that's a group 1. So it's still got a bit of colour, and then there's a straw colour. And if you've seen it over the years, you'll find that lubricants are getting much lighter in colour as they're going into a vehicle. That is now group 3, which has been very heavily hydro-treated. So group 2 and group 3 come out gin clear now. So that's the base oil that we're seeing now. The group 3 is what they're calling a synthetic. We're allowed to because it has so much treatment to get it to that, to remove all the organics and everything out of it. However, your true synthetics are your group 4, where they used to call them polyalpha olefins. And I don't want to get too heavy into the technical side of it, but they were truly man-made products. And a lot of those were made just from gases, where they hydrocracked in a catalytic cracker in the refinery. They would crack one base oil, and they would pull the gas off from out of that, and then they crack maybe the same oil again, but with a different catalyst, pull the gas off that, reform those two gases, and then you would end up with a PAO or polyalpha olefin to base your oil on. The problem with that is they were extremely good at building blocks, but they were very poor lubricant. So you had to rely on the additive pack for those, which is why they were that expensive. They were man-made, very expensive additive pack goes in them, which the end of those was a high-priced oil that goes in those vehicles. Because prior, like my days, used to be 5,000 miles drain period. Now you're looking at 20,000 Ks for a sump drain. And much higher temperatures, and that was sort of running in there. So there is a group 5, and group 5, it's mainly your brake fluids and that type of thing that are coming in those in that sort of an area. So that's all your base oils and that sort of thing that's coming out of that. And then the amount of derivatives that they can build out of that is what you build up all your oils from and what they can do. Emissions become a large part of this, so your sump drains have become longer because they want less waste oil in the market with that. Also, there's a lot of metals and that sort of thing, heavy metals that are coming in those products as well, from zincs and that type of thing that are used as additives, plus what comes out of the engine itself. So just on that, there's a distillation column, just on one of those ones that's in there. Basically, it finishes in with number 4 as it goes through from a crude oil. The green one is where it's de-waxed and sulphur's taken out of it. Then it goes to the hydrogenization process, which is with hydrogen, and they're just pulling out organics out of it. So you end up with that because they pull all the organics out of it. Because as you put oxygen and burning process to the organics, they become acidic, and then they start doing damage and they start sludging and that sort of thing in engines. They just start breaking down. So there's another process again after that now where they've gone to severe hydro cracking on that. So for a mineral oil, the goal of the refining process is to optimise the resulting properties. to produce a superior lubricant. So again, it just starts off with that base. And then, for instance, the thickness of that's actually an additive pack that goes into that base oil. Okay, so sometimes you'll hear about hot blending with oil. Some of you may have heard that we do hot blending. Main reason for that is that, as you can see, that's quite thick, and that's only part of what goes in. You've also got thickening agents and that sort of thing that go in there as well. So again, you need to heat those. That's part of that blending process so that it can actually homogenise right through the oil pack.
What sort of percentages of that?
It varies depending what you're making. Like you can get like a hydraulic oil that can be as low as what, about 10%?
0.6%.
0.6 in some of those, yeah.
They run at about 15%.
Yeah, it just depends. Transmission oils, they run quite high in a lot of those, on the additive. So, understanding viscosity. Now, I imagine you are very discerning people, but with the vehicles that you buy, and do many of you do your own servicing and service work on those vehicles? Yeah. So, the biggest part that we have is trying to explain what's sitting on a shelf, and that in there. So, if I look at one of these, I'll just hang a label of one of our bottles. But if you just look at that, the SNCF, do you all know what that means? And that on there, SNCF. The S component of that is spark ignition. So when you see an oil that starts with an S in the front, that means it's primarily for a petrol motor. The C means it can be used in a diesel engine of an early type, which is the F behind it, because we're up to CK now, okay, with that for a diesel. So when you see that sitting on the shelf, very quickly you can tell what it's designed for, what it's to go in. And then obviously you've got your viscosity sitting at the bottom of that. Same with this fellow, it's a C classification, so immediately that tells you that's a diesel, even though it's written on there it's a diesel, but it says CI 4 means 4-stroke diesel, and so the C and the I is this classification which came up to about 2002, 2003. So the next series after that was, you've got CJ and CK now coming up in that. And these are the things that we run into. Is that how many 530s are we doing now, Brent?
15.
So this is what's happening, is that the market is so fragmented now that, like BMW are calling for their own specifications, Holden are, Toyota, Mazda, everybody's calling their own bit. And then you get your Europeans, one coming in there with Eurosia, and then the Americans with their API classifications and SAE, and then the Japanese have also stuck their nose in there now, and they've got their JSO specifications and come in there as well. So we have to match all those for what those companies require. To form that, just to make that additive base, there's millions of dollars involved in that from the additive supplier, because it's destruction testing. So they have to destruction test those engines on test benches. In a diesel engine, some of them now, the engine has actually had to do 500,000 kilometres, and then it's tested. So the engine is actually built with 500,000 k's wear in it, and then that engine is tested because it has to pass its emissions testing at mid-life kilometres. So they're the sort of things that are running into building the new lubricants and going that way. With viscosity, I put a viscosity chart just in the back here. Now, what would you think? Is it like an 80-90 gear oil? Would that be heavier or lighter than a 2050 engine oil? Yeah. There's a lot of people, yeah, you're right, it's about the same. And because it's a different measure on the gear oil scale to what's measured on the engine oil scale. So your engine oil scale on this one, your crankcase, SAE crankcase is the green column. Okay, sorry about the blurriness of it. Then you look at your SAE gear oil one, this is the yellow one down the other side. So the 20, you'll see on here, in the green lines up with the ADW pretty well in the gear. and then your 50 lines up with the 90. So 80, 90, 20, 50. And this is where a lot of people get into trouble because they think that a heavier oil, like going to a 75W, is not. If you look down the bottom of the scale, 75 is actually right down low viscosity. Okay. That's
Could you tell an argument for me? I've got a friend who insists that his 1050 is at operating temperature a lighter oil than a 1550. And I say, no, the second number is what it's viscosity of the operating temperature, and the first number is just the cold operating temperature before it heats up. So, who's right?
Stick this chart on his nose. Because both these oils, if you look over the left-hand side, that's why I didn't want to get too deep into the chemical side of it, but if you look over this side, they're measured at two temperatures. Oil's measured at 40 degrees C, and then it's measured at 100 degrees C. Now, what that means is that when you have this oil here, which is a 1050, which your friend was talking about, that oil exhibits the characteristics of a straight 10W at 40 degrees, okay? And then when the temperature is raised up to 100 degrees, it exhibits the characteristics of what a 50's thickness would be at 100 degrees. It's not that the oil gets thicker when it's heated up. You actually need to picture, if you picture a clock spring, when you wind that clock spring right up, so that molecule of oil, the polymer that's in there is wound right up tight, so it's a small molecule. As you heat that molecule up, it expands and it sort of retards the oil from thinning out. Doesn't let it thicken, it just retards it. But then it gets to a certain point, it can't unwind anymore like a clock spring, and then it just falls over the cliff.
So I've got a 50 weight at 100 degrees, regardless of what the control temperature is, will have the same properties that the operating temperature. So the two oils with different low temperature ratings, like say 1050 versus 2050 oil. The 50, when they reach operating temperature, they display the same lubricating properties.
That's correct. So at a 50 grade oil, at a 1050 oil, as I said, at 100 degrees exhibits what a 50 would be if it was a straight 50 was heated up to 100 degrees. Okay, so because we're talking multi-grade, that's why it's a multi-grade.
It's funny because, like I say, I get people who will argue with me about this, and people who should know better, like people who work in mechanics and so forth, will tell you that at operating temperature, the first number makes a difference in terms of the final properties.
Some people call it the W, they call it winter temperature. But really, winter is not 40 degrees. It's just a class of measurement. But most of the measurements now that are coming in that we're seeing a lot of, which are much more accurate, is the ISO measurements down that side there. So you look at, for instance, a hydraulic oil, which could be a 68. You look across it, it'll be a 20, and then it'll be an 80W. So, that's what I said, you need to look at how they're classified in different businesses. I've listed that over a time frame for some of you that are interested, the BMW oils over that period and the engines that they go in and that sort of thing as well. So I'm just going to run through some of the additives and that sort of thing as well, and then just sort of get into some of the racing products. And sorry if I'm boring some of the ladies to death and some of the other guys, but it's just, the trouble is it's just a big mixture, and to try and do 45 years into half an hour is pretty difficult. But so we're looking at, so your anti-wear additives, also known as friction modifiers. These additives obviously reduce friction, prevent metal-to-metal direct contact. Now the way some of those additives work, they are heat and load activated. So they do absolutely nothing in there until they come under load and heat. They're there to protect those two metal surfaces. So what happens is that self-sacrificing. So if you've got an engine that's working extremely hard and under high load, high temperature, you will suck that additive down quite low. And that's why we do oil testing and that sort of thing as well, like use oil testing to see just how far you've pulled additive down out of that engine. So the main one that was been around the market for a long time, you always hear people talking about zinc. I don't know, the zinc dialkyl is your ZDDP, which is the zinc additive for anti-wear. Thing is that everyone waffles about this. We've decided with some of the racing oils to go a lower zinc level, but we've got the synergistic effect now of we've been adding titanium dioxide to that. So the titanium dioxide, it actually treats the metal surfaces and that in there, so you get a surface treatment of the metal, and then on top of that you're getting the zinc component and that in there as well. And given that racing oils are usually 1 meeting oil, a lot of those anyway, you don't go racing and then the oil stays in the car, particularly if you're going to drag racing, you're using nitro fuels, alcohol fuels, all that sort of thing. You must drain them out because they're hygroscopic, they draw water to themselves, you start getting rust issues inside the motor. So again, there's so much that goes into that. That's right. We're also using a potassium borate ester in that as well. We use those in the heavier. So we do a 25-60 viscosity oil and a 40-70, which is mainly for you're looking at some drag racing and that type of thing as well, and touring car type racing with the V8s. So the borate, same thing again. It's a metal surface treatment that's coming in through there, as well as the zinc, but it's capable of taking a very, very high load, high heat in that application. But it's usually made for engines that have got fairly high clearances because you're using a lot heavier oil. They've got much more clearance in the bearings and that in there. Okay. Thought you said it wasn't going to be technical, Brent. Okay. So I'll just list some determining factors when we are looking at making an oil for racing. So some of you are interested in racing side of it, so this is why I just sort of put that together. So again, the type of performance engines that you're looking at are either your endurance, sprint, drag racing, motorcycle, your boat racing as well. You're looking at different induction systems. You're looking at carburetor, fuel injection, forced induction, turbocharging, and your supercharging. All those jam extra fuel into the sump, so we have to contend with that. So you've got various fuels going in as well. So you've got high octane motor spirits going in there. You've got ethanol, methanol, nitromethane, and you also have other they're called oxygenators that are going in them as well. To some of these vehicles, you go into two-stroke, your synthetic, and you've got your caster-based oils as well. So Castrol used to make, years ago, they were making caster-based oils for motorcycle racing and that type of thing. Used to have a nice smell to it, but geez, they were dirty. But so methanol, as I said before, methanol fuels are very hygroscopic. Hygroscopic meaning it wants to draw water to itself. They're mostly 1 meeting oil. So your engine specifications to be considered as well as your operating RPM and the duration of that. So for instance, in drag racing, so a 4.5 second pass in a top fuel at 7,500 RPM, that engine's only turned 850 revolutions. So from the line to the quarter mile finish line, that motor's only turned 850 revolutions, and it's usually a smoking wreck when it gets to the other end. It's either kick the rod out or something like that. So it's just the amount of power that thing is generating through the type of fuel and also forced induction that's going into those motors. So these engines produce 6.5 to 7,000 horsepower, which meaning they're doing about 800 horsepower per cylinder in a nitro engine, which if you're looking at a V8 touring car, is about 650. So they're doing 150 horsepower more in one cylinder than what that V8's doing. But it doesn't last quite as long. It's all over in about 4 seconds for it. So, yeah. Well, they reckon how do you make $1 million in drag racing? You start with 3. It's pretty well it. That was the thing. So again, one of the biggest determinators for us is bearing clearances. That's running that to making it oil. So as bearing clearances come down, we're looking for oil pumps that are going to put through. You want good flow from an oil pump. Everybody's going pressure. Everyone wants hole through that motor if you're not careful with that. So we're looking for high volume in a race engine so that it's actually pulling away the heat from the source that's making it, and also it's taking away the detritus material and that out of there. So you want high flow, good oil pressure, but high flow. Those type of motors. Okay, so again, race engine with tyre tolerances with a high volume pressure oil pump, an engine at 9,000 RPM. a 2560 at ambient temperature will create enough viscous drag to actually spin the bearing shell out of the conrod. So it's got that much viscous drag, it will actually pull the bearing out of the conrod and destroy the motor. So if you've gone too heavy in the oil, too much viscous drag, it will kill the engine. So and alternatively, a 020, like we were talking about before here, 020 in an engine with wide clearances of about 2.5 thou, is just not enough there for it to, we call it a hydrodynamic wedge. So the oil has to form a hydrodynamic wedge. So when you get rotational speed from a crankshaft, picking up the oil, it's actually picking up a wedge, and that wedge causes separation between the two metal surfaces, and it actually rides on that, it floats on that. If you run too light an oil in there, with too big a clearance, it's losing the oil too quickly, can't form the wedge. So again, camshaft configurations, you're going from overhead cams, multiple cams, or you're going push rod. So these are flat taper cams with the push rods. That's where your additive comes into consideration again with the zinc. Synthetic lubricants, they're not always the answer to a situation. The example was Larry Perkins. We did the oils for him. Not with this company, but we did oils in the past for him. And he picked up about 6 horsepower by going to full synthetic. This is back in the early days in the 90s. So he went full synthetic engine, transmission, diff, and that through there. And he picked up about 6 horsepower, which was significant. If you're going down Conrod Straight or something like that, it just gives you that bit to go a little bit quicker past them. Problem was that what he found out was that you have Torrington bearings in your lifters and also in your roller rockers, and they were pounding, they weren't turning, because the oil was that slippery and that light, it wasn't having the Torrington bearings turn around anymore, so they were just on a flat. So it was wearing the shafts flat and that in there. So I had to change the oil formulation so that it had enough tackiness in there so that it would actually turn the bearings around in there. Now, just little things like this, by changing one thing, it caused another. With that. So heat and engine temperature is a major consideration with high performance engines and lubricant selection. Motorcycles, again, they're a headache because the amount of horsepower the motorcycle is now producing per litre of engine is phenomenal. So you're not only doing high revolutions, you're doing high heat, but you're also trying to lubricate a transmission all in one go. So again, motorcycles are very, very hard on oils and that type of thing in there. So they're the sort of things that we're going to synthetics in, and they perform very well. We have a broad range, in the titanium range. I mean, there's some little brochures I've got here somewhere. There they are. So you have your 530s, 540s. 540s are very common, in these modern motors now. So your 540s, 1050s, 2560s, and 4070s that cover that range of racing. So you have a huge amount of additives that we're sort of looking at, which is again looking at extreme pressure additives, which the differentials take, and gearboxes, they take extreme pressure additives. Again, those additives are sulfur phosphor, sulfur chlorine based, a lot of those. And again, they're not really activated until you're in city driving. Those ones. So a taxi will wear out. Like we're seeing these days that they've got filled for life on some of the differentials. That's total crap. If you're driving a taxi and you're on, off at the traffic lights all the time, every time he takes off with a hot differential, he's wearing out the additive pack that's in there. Once that's worn out, all you're left with is just the base oil. Your additives are gone. There goes the diff, the bearings. You may as well just throw it away. So yes, you do need to change the oil from time to time in vehicles like that. So this fill for life thing is always a bit of a worry, and with transmissions as well. Your EP additives are also found in your greases, that type of thing with that. Viscosity improvers and pour point depressants, that would have a pour point depressant in there. Meeting cold temperature, it stops it from forming waxes and that in the oil. Wax has already been removed, a lot of it's already been removed out of the oil in that refining process. You've got anti-foaming agents, I think usually silicons and that sort of thing, aren't they? Yeah. So, and that's what's being added into your diesel fuel now. If you fill up with, some of you might own diesels, I'm not sure whether you do. When you fill up with diesel now, if you did that 10 years ago, you would see foaming coming out of the tank, and you would have aeration, and you would probably not getting your full charge of fuel that you thought you were. Now you don't see that anymore. There is, because of the silicon that they've added to the fuel, it's just filling it right up. There's no aeration, because if there's aeration of the diesel, you lose performance, because then you got very fine molecules of air. You can't compress the fuel, but you can compress the air. So you're actually filling up that chamber, but you're squishing it down. So you need to use more throttle position to actually get that engine to perform. So, antioxidants, which of course, as we said, green dinosaur juice, it's going to have oxidisation material and that sort of thing in there. So we have to remove that through a refining process, otherwise you're just going to get acids and sludge building up in there. Metal deactivators, which is just like corrosion inhibitors and sort of thing coming in. Because that motor has so many different components in there, where you've got rubbers, you've got aluminium, you've got brass, you've got steel, that's all running through that engine. You need to make those inert and deactivate those, otherwise they'll react with one another. It's usually the alloy parts that go first, through any corrosion, through acids and that. So you'll start seeing pistons dissolving and disappearing. There's also detergents and that in there, because the only way that you're going to get the rubbish out of an engine after it's been run is by having detergents, and they form a skin around the molecules of acids and everything that's in there, and they can only be taken out of that motor by taking the plug out and draining it at the end of the day. You've got Tachiness agents, which I'm sure you've seen commercials on there from another company with molecular this, that and the other. Well, it's just a Tachiness agent that keeps it into contact. So with a camshaft and that type of thing, and going to these light oils now, they run back down into the sump rather quickly. So you need to have a Tachiness agent in those that will hold it on those metal surfaces for that. We actually produce products for farming, for instance, where when they finished an additive to that, which slowly breaks down in the oil, which actually coats those gears until next season. Seal swell agents, they're obviously the different types of materials that are sealing an engine now. Those seal swell agents have to keep those seals in check. When I was with BP, we had a major problem with we changed the makeup of the fuel, and it cost them 16 million roughly Australia-wide, where they replaced just about every neoprene seal in every old Toyota, Massey Ferguson tractor and all that sort of thing out there. Because what happened was when they removed some of the aromatics out of that fuel, the seals that had swollen up because of those aromatics being there sealed the engine. Once those aromatics were removed, the seals returned back to their original shape and leaked like a sieve. So they had to be replaced. So again, look, current and future trends, vehicle manufacturers' pressure is, as I said before, like Brent was saying, we've got about 15 already of those light type engine oils. And it was just seeing significant changes in fuel composition. Europe had a major dieselification of the market for many years over there, and we were a bit slow, we were a bit behind that because our fuels weren't right up there with it. Like for we had X5 BMWs that they couldn't bring out here, the diesels, simply because the fuel was above 50 parts per million at the time, which they just didn't run on. It just wasn't good for them. Now that that's dropped down, because we used to be at 5,000 parts per million sulphur, then they dropped to 500, then they dropped to 50, now we're down to sub 10. So that's why you're seeing a big dieselification of the market here. But now we're also seeing a turnaround where you've got direct injection petrol going into some of these vehicles now. Before they were injected into the ports, now they're just injected straight into the cylinder, and then you're getting turbochargers coming out, so you've got small capacity motors with turbochargers pushing it pretty hard in there. And the manufacturers are trying to get what they call stoichiometric effect. Stoichiometric effect is where you have your fuel and air ratio exactly at that point where you're getting the biggest bang for your bucks out of it. So, and that's computers are doing all that for us now. Yeah, we're never done. So again, there's growing dependence upon synthetic base oils. We're just seeing a massive increase in the market in that. And over time, like synthetics were incredibly expensive some years ago. They've actually come down a bit over time, but we're now seeing some problems in the industry where we're not producing enough anymore because of the jet fuel saga out there. They're blaming it on jet fuel that's sitting there. I think, what was it, to make 1 barrel of lubricant, you required 10 barrels of crude base, wasn't it?
Yes.
Yeah, so to make 1 barrel of lubricating base oil, you required 10 barrels of crude. Problem with that is that you've got to find a home for the other 9 barrels that come out of that crude, which is either bitumen, it's going to be unleaded, it's going to be Kero, or Jet A. So there's tankers now sitting around the world full of Jet A. Can't get rid of it. Which will, yeah. So also there's reduced metal requirements, heavy metals, so they won't take zinc out of the formulations as well. There's reduced sump capacities we're seeing in a lot of vehicles. So they're increasing the service interval, but they're reducing the sump capacity. So the oils have to be right up there. And lighter viscosity oils is where we're really heading. And as I said, 1990 we're still using, one of our biggest sellers was still the 2050. And now, as I said, we're heading towards 0.16 and probably 0.8 in the future. So that's me. So questions, please.
When you're looking at older cars, so cars that were, say, 30 years old now, when 2050 was the standard,
Yep.
they probably had engines, so the additives, it's not just the weight, but the additives, which will probably change over the years. So what's your general recommendation for with those older cars?
What we usually do, and we've again, we cured some problems for some Mack trucks at one stage. They were 575 horsepower Mack V8 diesels. They were built in 1985. So what's been happening is they've been putting 2015, 2017 oil in these things, and they just got oil running out the exhaust on them. They just don't respond to it because they were never designed for it. When we went back and put them on the oil it was what they call Mackie OK at the time, you put them back on that oil, end of problem. And they just settled back in. They were quite happy. You had to lower the the service interval. You couldn't push them out of that long-range service interval. You just had to cut them back to about 10 or 15,000 Ks, and they were fine. They're happy on that because that's what it was designed for back in 1986. And that's really what you should be looking at too, is when you're running that type of vehicle, if it's built back or rebuilt back into those same specifications, then yeah, that's what we need to do. Look up on the website. Owners' manuals have a lot of that in there, with the old specifications. In that, well, if you go back into that type of oil to that period, it's already got the correct level of zinc in there. You know, for instance.
By 2050 today, it'll have to do the same amount of zinc.
Yeah, pretty well. Yeah, like ours is what's called Senso Classic or something like that. And that's
sort of
more modern.
API classifications.
Yeah.
Really need to look at, and they're all supposed to be backwards compatible in the actual service. If you're trying to go back half a dozen classifications, you're probably going to be looking at an earlier type.
Okay, we need to wrap it up. Sorry, guys.
No, you're right.
Yeah. But look, thank you very much. We've obviously just skimmed on the very surface.
It is
but
the tip of the iceberg.
I think we'd like to possibly do this a little bit more in depth. We might try and organise a tech day or something.
What we could do for you, if you like, is we got our boardroom and that up there, and we could also organise that you actually go through our plant and you actually see how things are made. Is that all right, Brett? Should I
Just say yes, Brett.
Should I ask Brent first?
Well, we offer to our customers.
Yeah. So we're more than happy for you to come through there, and you can actually see how all these things are done, how they're made, and what goes sort of in behind it.
It obviously needs to devote a lot more time than we've allowed you this evening. I'm sorry about that, but thank you very much, everyone, for that.
Thank you for the invitation.